Assalamu alaikum. This is MATLAB course lecture number 10. It is the MATLAB simulink. The MATLAB simulink, it is a tool that can be used to simulate a system of equations or dynamic systems or whatever, any system, using simple tools. How we can start? We have to go to new. From the new, we have to select, as you see, simulink model. Once the simulink browser opened like this, guys, we have to select. Like the MATLAB application, you have option to start from the blank model or say that blank library or blank project or folder, or you can select from one of other examples here, fixed step templates or signal processing or whatever. So I will start blank one. Now I see this is the area where you have to design your simulink system. Let me solve the first class exercise. We have ODE, differential equation, where a second derivative plus 2 first derivative plus y 5 times y equal 1. Initial condition y dot of 0 equal y of 0 equal to 0. Now to solve, before solving the exercise, as you see here, we have the area. In this area, white area, we have an area to design our simulink system. We have some tools here to zoom, navigate, and this one is very important. It's the library browser. I will click on the library browser. As you see, we have a library, the tools that we have. As you see in these tools, we have simulink here. Open the simulink. We have commonly used blocks like the gain, like convert, like constant, like bus creator. We have many of integrators. This is most common used. If you want continuous functions like integrator, if you have a dashboard, if you want dashboard, you have many dashboard here. As you see, we can use this custom gauge, this gauge, half gauge. You have discontinuous, if you have some functions for discontinuous functions, discrete, logic bits, and bit operators. You have sinks, we have sources, sync like scope, like to save to file, sim out to workspace, XY graph, source like constant, like clock, like digital, like simn, take from the command window to the simulink. Input, we have ground, we have RAM function, you have many sources here. So we have also math. Let me show you the math operators, operations like add, like absolute, dot product, divide, gain, find. We have many math functions here. So how we can start to solve this problem? You have to know what are the components we need. Let me look to the problem again. As you see in the problem, it says that use simulink to model the following differential equation. So we have here, the first thing, guys, it's better to rearrange this equation so that the second derivative to the left equal minus 2 first derivative minus 5y plus 1. So we need the factor 5, the constant, sorry, 5. We need the signal y, we need the signal of y dot, and we need the signal of y double dot, and we need the constant 1. So these are the components. So let me go to commonly used one. Let me take the constant. This is 1. As you see, this is the new one. By the way, guys, if you double click on this component, you see there are a brief help about it. I'll put the constant specified by constant value. What's the current value? It is 1. It could be a variable name, k, y, j, yes, anything. So the current value, it's 1. Keep it like this. Okay. Now you can double click here beside under the block just to say that this is just constant. Constant. You can name it constant or remove the name like this. We can click here, copy, paste, if you wish, copy, paste to create another, Control C, then Control V to create another one. Okay. I will delete this one. Or we can double click on the space like this and say we want constant. See, constant. It will bring the block directly. What's the constant value here? It should be 5 this time. 5. Press 5, enter. It will take it. If you don't want like this, double click and change it from here as 5. We need also, as you see here, in the solution we have the second derivative equal. So we need the second derivative, we need the first derivative, and we need y. So I will make them at the beginning as constants. This is the first constant, this is y, say that this is double y dot, y double dot. At the beginning, say that this is y, okay. I don't know the solution of y. It should be constant value. Anyway, keep it 1, never mind. Keep it 1, never mind, but name it here under the constant. Name it y. Okay, I will change it later, don't worry. And this one, name it y dot. Okay, and here y double dot. Now, the equation, it says that second derivative, which is y double dot, equal to. So it's equal to what? Keep this one here. It's equal to, we need minus 2 dy over dt. Where is dy over dt? This one, dy over dt. This one should be multiplied by minus 2. Minus 2. Say that I want a gain. I will take the gain like this. What the value of the gain here? The value of the gain, you can take it from here or from the window directly. Minus 2. So the gain minus 2. How to connect? Click here and click here. You can size it and move it like this. So remember that this is y dot multiplied by minus 2. This is the this term. We need also when you take the 5y to the right, it will be minus also. We need the same. We need the gain. Control C, Control V, gain. But this gain this time it should be this constant, which is 5. So this should be say that minus 1 like this. Okay. Just to show you an example, take the 5. Okay, connect the 5 to the gain of minus 1, it will be minus 5. And now we should multiply it by y by y. We need multiplication. Double click here, right, multiplication. This is multiplication. Okay, this is multiply, which is the gain. No, I don't want the gain. We need not multiplication. It is I forgot the name. Let me go back to the math operators here. Add, no. We have this one, which is divide. So bring it like this. Okay, now the minus 5 connected to the multiplication. Double click to change the second one. So the first, it is multiplied. Second, it is multiplied also. So this will be multiplication. So we have to multiply y. Where is the y? This is the y. Multiply it by minus 5. So this is the minus 5y. This is the minus 5y. Okay, and this is the minus 2y dot. If you add them together with the 1, so what I will do, I will add all of these to 1. The result should be y double dot. So we need to add. In the addition here, we have 3 terms, not 2. We can add more plus. See, plus, plus, plus. Okay, now we have 3. We can size them like this, if you wish. Size it like this. Connect the 1 to the first term. Connect this one to the second one. Connect this one to the second one. Actually, this representation represents this equation. Now, y double dot equal minus 2y dot minus 5y plus 1 plus 1. The result, it should be what from here? Come from here. The result, it should be the y double dot. The y double dot. Now, the y double dot, if the y double dot integrated once, it should give us the y dot, the first derivative. The second derivative, if it is integrated, it will give us the first derivative. So where is the integrator here? Integrator from math. Okay, I think it's in the continuous functions here. Yes, integrator. This is the integrator. Connect this one to here. Remember that you can, by the way, guys, we can add a text just to show the bus here or the signal come from here. What's its name? Now, if you double click, it shows us or give us opportunity to add element. I don't want to add element. I want to create annotation. Click here. What is annotation? This should be y double dot. Okay. Now the signal goes out from this one. It should be y dot after integration. Y dot. So this would be y dot. If you integrate the y dot again, so Control C for integrator, Control V again, connect this one to here. Remember that the output from here, double click again, create annotation, the output should be y dot. So integrate the y dot again, it should give you y. So the result come from here, guys, double click here, same thing, it should be y. This is the way. Take the y outside like this. You can change this one like this. I know that this y should go to, if you want to show it on telescope, sorry, in the, let me go to sync. From the sync we can take the scope, this one. Okay, you can delete this one, the old one, click and delete, connect the scope. I don't know why not working. Let me go back. No, not floating scope, this one. Okay, delete the bus again, connect them again. Now the signal go after second integration, it should be y. It will go to scope. Now the y, as you see the solution, it's like a loop. The solution of y, where is y here? This y. I will delete this y. I will delete this bus here. Then I will take the mouse to here, then control. Then take this y back to here. Connect it to here. Now don't forget that this is a y. Don't worry, the simulink, it will make a loop and try to find the value of y. So, but this is, just to remind you, this is y signal. Same thing for y dot. Where is y dot? We need y dot here. I will remove the y dot from here. It should not be a constant, it should be y dot. Then I will take a signal from here, then control and use the mouse and connect like this. And just, we can make it like this to make it more simple. And you can move it like this also, just to show you here. We can show that this is here y dot, again y dot. Now it's okay. Now the solution is complete. Again, the equation is, we have to simplify the equation or rewrite it so that in the left side we have the second derivative equal, in the right side 2 multiplied by first derivative, minus 2, sorry, multiplied by first derivative, minus 5 multiplied by y plus 1. So this is plus 1. This is minus 2 y dot. And here we have minus 5 multiplied by y, like this. We can arrange it anytime, guys. We can resize, we can move, we can do many things like this. So this is the y, should be like this. Okay, now the result from this, say that loop and component, it will be the y, but we have to take care about integration. Double click on the integration. See, the initial condition, it's 0. We are talking about y when time equal to 0, it is 0 or 5 or minus 2. So as you see here, y at the beginning, it will be 0, so keep it 0 like this. Okay, what about the second integration? Sorry, this one, for the y it should be 0, but for the y dot, it should be 0 also. So the initial condition here, it is 0. So we want to plot the y function of time. There are no unknowns here. This is 5, this is minus 2, the gain, this is 1. It's ready. Now let me save our application, or sorry, simulink. Say that lecture 10 part 1 SLX, that means simulink, MATLAB simulink. Now it's okay, but this one, it's an extra, we will delete it. Save again. Now let us run. Before running, guys, we have to go to model configuration parameters. As you see in the parameters here, we have we can indicate the start time, the end time, the increment, everything, the step. So the solver start time, it is 0 to 10 seconds only, it's okay. Solver selection variable step, it's okay. Automatic step, if you want a fixed step, you can use the solver, and how much or what is the fixed step like this. So keep it variable step, never mind. Apply. Okay. Now let me run the simulink. Now the simulink, it's okay. We got some warning. If you look to the command window, nothing happened, no errors. But if you look to workspace, we have the out. Double click on the out, it will be see the time. This is the time vector from, if you remember, from 0 to 10 seconds, and the corresponding here, the simulation data here. We have some data here. Error message, it's empty, nothing. That means we don't have errors. Now, where is the plot? It's in the scope. How we can show the plot on the scope? Double click on the scope and wait. Yes, as you see, this is the solution. This is the y versus time. You want to say that scale it in scale the y, scale the axis, x-axis, fit like this. Also, we have some properties here. You can do something here, a number of inputs. You can change it. If you have 2 inputs, you can change it to 2. Regarding the time, regarding the display, we have some options here, logging. How we can show the legend if you have more than one plot. Here we have legend. You can change the layout like this if you have 2 or 4 graphs, 2 graphs like this, 2 graphs like this, as you see here. But we have just 1 graph, so I will go to back to layout, keep it 1 by 1. I will close it. Say that I want 2 inputs, guys, 2 inputs. Let me go to tools again, or options again. Select number of inputs, say 2 instead of 1. What they are, and the layout. How the layout? It is should be in 1 row like this. Okay. I will close it. See here we have 2 plots, not 1 plot. Say that I want to plot the y and the y dot at the same time. So where is the y dot? This is the y dot here. So let me delete this one. I will make it like this. I will resize the scope like this. Okay, I will connect y. I will connect y, control and hold, and like this, and control again. Pick the mouse, put it here, and hold like this. Okay, now we have 2 signals, the y and y dot. You can just double click annotation. This is y dot, just to remind yourself that this is y dot. You can move it up like this. So we have 2 graphs here. The first one, it will be y dot. The second one, it will be y. Save your work, then run program again. We don't have mistakes. We have sim out. Double click on the scope. As you see, we have 2 graphs here. 2 graphs here. If you want to plot them in 1 graph, not 2, like this. Okay, we will go back to the properties, make the number of inputs, it is just 1, just 1, apply. And regarding the layout also, regarding the layout, it should be 1 by 1, like this. It will give you two drawings in 1, 2 drawings in 1. But this one disconnected, I will remove it like this. Y dot, okay. Now I want to plot y and y dot together in one say that in one scope. So we have to go to the library and go to commonly used one. Say that we have here not the max, we have the max. Okay, the max, it will mix signals together. So we have to go to here, control, click and take it here, and go to y, control, click and take here. Now we are mixing the 2 signals, y dot and y together. Now I will plot them in one, I will plot them in one scope, in one axis. Save. As you see, we have 2 signals in one. We have max, mixer to mix them together. Then run now. After run, double click on the scope. See, we have both of them. Now we can go to tools or view, make legend. I see legend. We have legend here, and you have y, and here integrator. Double click on the integrator. You can see that this is y dot, like this. Okay, see the increment. It's variable increment. You can change it. So the blue one, it is the y, and the yellow one, it is the y dot, the velocity. We have many components here that we can use, many components, and we can solve the same problem using different than one method. By the way, guys, if you want to, as example, you want to merge all of these together, make them as a subsystem. Just let me move this one a little bit up, or keep it Control Z, keep it like this. I will take care, I will select all of these together. See, I will right click here and make them as subsystem. Where is subsystem here? Not selected, by the way, by mistake. Okay, let me select all of these and right click like this. It will disappear. Okay, later on in a second example I will show you how we can make a sub system. Regarding subsystem, just click here. See, we have here some options. Create subsystem, we have to create enabled subsystem, and we have many options here. I will create subsystem like this. So for this subsystem, you can name it any name. You can double click, and as you see, this is the inner block, and you can do what you want. Now this is subsystem. I will go to lecture number 8. You want if you want like this, it's okay. If you want to keep it before, undo like this. This is the first say that example. Thank you so much. See you in next video.